I have always liked fish as a kid, especially keeping them, selling them, breeding them, and catching them as a kid, as you can see here. I've kept many big fish such as Oscars and barramundi. However, I've wanted to crossbreed guppies recently. In the past, I've bred hundreds of guppies, but I only got these common guppies. Yet wanted something rarely seen before, which is why I am aiming to genetically cross a 24K gold male guppy and 2 female glass-bellied guppies and observe their offspring over a 6-week period. I hypothesize when you cross a 24K gold male guppy and 2 female gold glass-bellied guppies that the offspring will take only the 24K gold traits, which include a golden body, tail, and not taking on the traits of having a transparent belly and no ringed eyes. Variables. The independent variable. What am I changing? I'm changing the genetic combination of the parents, since usually the parents would breed with the same species. Instead, I'm forcing them to breed with different species. The dependent variable. What am I measuring? I'm measuring the phenotypic traits of the fry over a 6-week period, as the 24K gold guppy and glass-bellied guppy have different traits, as you can see here. The controlled variable. What am I keeping the same? I'm keeping the same water temperature, which is 26 to 27 degrees. I'm keeping the same food, which is brine shrimp and crushed flakes, and I'm keeping the same lighting, which is 14 to 15 hours per day. The co-founding variable. It is an unmonitored accidental variable which can change the results of an experiment. The problem in my experiment is the female glass-bellied guppies I had been previously with male glass-bellied guppies, which could mean it has stored the sperm from them, which could mean that the fry is just glass-bellied guppies and not a crossbreed. Materials. In this experiment, I'll be needing guppies, a 30-litre container, 52-litre fish tank, 2 sponge filters, 2 aerators, 2 LED lights, aquarium gravel, aquarium plants, a Plenplax aquarium, aquarium net, and fish food. The method. First, select a purebred 24K gold male guppy and 2 female gold glass-bellied guppies. 2. Put the male and female guppies in a fish tank which is at least 20 litres and make sure it's heated at 24 to 28 degrees. Use fish-safe water and a filter. This is to ensure that they have mated. 3. Move the female to a Plenplax breeding box, or move them in a separate container with similar water conditions to the original tank. 4. Wait for the fry to be born. It takes approximately 22 to 35 days. 5. Once the female has given birth, remove her from the container so they won't eat the fry. 6. Leave the fry to grow in a tank/container and wait till they grow big enough and observe their colours over 6 weeks. Risk assessment. Electrocution. Make sure the power board, which is connected to the heater and filter, is dry and safe position. In emergency, call 000 and turn off the power immediately. Glass cracking. Do not put any pressure on anything made out of glass, including the fish tank lid. If you have a small injury, use a first aid kit or call 000 if it's more serious. After treating injuries, dry the floor for water. Slipping. Keep a dry floor towel to wipe any moisture. In the injury, treat bruises with ice and check for any broken glass. Zoonotic infections. Wash your hands and forearms after cleaning tank water or the filter. Depending on the type of emergency, for example, fish water going into your eyes, clean it out or search up what to do. The experiment. I left the guppies in the Plenplax aquarium for a couple of weeks. I could tell they were getting highly stressed. The breeding box was getting very dirty and it only had a very small amount of space. So I ended up moving them in a 30-litre container where the sponge filters the same plants and water temperature. And the females gave birth shortly after, as you can see here. About 4 days later, the second batch of fry were laid, as you can see here. They seemed pretty healthy and ate straight away, however. Some fry were at the bottom of the tank, however, I think it's just them still developing. Week 2. After rechecking, there was about 20 to 30 fry, which is more than I originally thought. I continued feeding them about 3 to 4 times a day, baby brine shrimp as you can see here, and crushed flakes. In addition, I also did regular water changes every 3 days to maintain high water quality to maximize optimal growth. Week 3. I moved the fish into a 50-litre aquarium, which would maximize their growth because the large amount of volume is equivalent to the speed of their growth. The tank has the same stuff as the previous stuff, such as substrate, plants, lighting, aerator, and a 26-degree heater. Whilst moving them, I was able to count exactly 26 guppies. Week 4. By now I could see some unique traits of the guppies. These ones here were blackish grey, while these ones here were more like smaller versions of glass-bellied guppies. However, I couldn't see any gold emerging yet. Week 5. By now I could see a lot more colour, however they still weren't fully grown yet. As you can see here, a lot of them were this blackish grey colour, which was kind of confusing to me, while the other batch were glass-bellied guppies. Week 6. By now they were juveniles and you can see a bit of the colour. Some of them were developing a bit of a yellowish gold colour, however none of them were fully golden yet. Results. After taking a photo and carefully counting each guppy, I created a pie graph. 12 of the guppies possess phenotypes of glass-bellied guppies having no ringed iris, a transparent belly, and gold tail, whilst 10 of them were black/gold while having mainly a golden tail, and 2 of them were fully black/grey. I also created a timeline to show their growth over the 6-week period. Discussion. During my experiment, I encountered errors such as measurement and human errors and coloured biasness. This is because it's easy to misidentify small traits such as the iris rings. My second error is sperm storage because guppies are live bearers, meaning they can store sperm for months, and since my 2 female glass-bellied guppies grew up with other male glass-bellied guppies, it could have meant they stored sperm from them. And I think this actually happened because, according to DNA, the glass-bellied guppies are a recessive gene compared to the 24K gold guppies, which means most likely one of the 2 females stored sperm from a male glass-bellied guppy previously. A big error I ran into was a time error, since guppies usually take 2 to 4 months to become fully adults. However, being juvenile, they could show some colour still, but not their full colour, so I couldn't get fully accurate and the best results. I think the reason many of my guppies are darker or black colours, even though the parents don't have any black colours, is due to the reason that dark pigmentation shows up first before the other colours, and this can be seen as gold is starting to appear on many of the tails of the guppies. In conclusion, my original hypothesis was not supported by my experimental data, as I originally hypothesized that the F1 generation will look like 24K gold guppies and possess the same phenotypes. However, after a 6-week observation period, 50% of the fry possessed phenotype of gold glass-bellied guppies, 42% possessed a gold tail and black body and fins, and 8% possessed a fully black body and black fins. This could suggest the parents had a heterozygous inheritance. Evaluation. Reliability was moderate. While I had a sample size of 24 providing clear data, only using one male 24K gold guppy means the genetic anomalies could be a skewed outcome. To improve my reliability, I would replicate the experiment over multiple 24K gold guppies. Validity was moderate, although environmental parameters like water quality and feeding were strictly controlled. Sperm storage of the female would impact the results. For future research, I would have to make sure the females haven't mated before. Accuracy was low because 6 weeks wasn't enough time to see the full maturity and colours of the guppies. With more time in the future, I could have a more precise and accurate classification of the phenotypes.